have you all in attendance and have the resources to be able to provide presentations like this. We have an excellent panel that are here to talk to you today, and then some are returning on Thursday, and I want to introduce you to them right now. First, we'll hear from Elizabeth Hilton. Elizabeth Hilton is the Geometric Design Program Manager for the FHWA Office of Infrastructure, where she provides expertise on geometric design, accessible design, bicycle and pedestrian accommodations. Elizabeth is FHWA's liaison to the AASHTO Technical Committee on Geometric Design, and prior to joining FHWA in 2009, she enjoyed a 28-year career with the Texas Department of Transportation, where she served as a member of the U.S. Access Board's Public Rights-of-Way Access Advisory Committee. So, Elizabeth, we're glad to have you here with us today. We'll then hear from Janet Barlow. Janet is a certified orientation and mobility specialist with accessible design for the blind. Janet has extensive experience teaching travel and street crossing skills to individuals who are blind or who have low vision. And for the past 20 years, she's worked on research related to accessibility of sidewalks and street crossings to pedestrians with disabilities, focusing mainly on travel by pedestrians who are blind or visually impaired in complex environments, particularly street crossings. We're lucky to have Janet joining us as well. Finally, we'll be hearing from Dr. Robert Wall Emerson, who is a professor in and the coordinator of the Department of Blindness and Low Vision Studies at Western Michigan University. He's a certified orientation and mobility specialist and has worked as a teacher of children who are blind and has been conducting research into aspects of blind travel for over 25 years. He's published more than 75 peer-reviewed articles and 7 book chapters on a wide variety of topics involving navigation of people who are blind and teaching children who are blind. So I hopefully you all are as excited as I am to have this panel here today to lead us through these presentations. I want to say just a few words of housekeeping right at the outset. You may be wondering about where to access some of the materials related to this webinar, things like a copy of the slide presentations, the video recording when it's available, and some of that material. And I can tell you that that's all being archived at our website. If you visit pedbikeinfo.org/webinars, you'll be able to find all of that information. I pushed that out to the chat pod just a moment ago. I'll remind you about that a little bit later in the webinar, just so you have that information handy. You can then, because of that, you can look back at the material and review the material that we are sharing today, both the slide presentations themselves and the video recording, which we hope to have up fairly soon after the webinar is completed. So that'll all be accessible to you. We will also be reminding you a little bit later in the session about how you can go about generating a certificate of attendance for the webinar. The webinar has been submitted to and approved by the American Institute of Certified Planners, AICP, for 1.5 CM credits. We'll be providing a link that you can use to generate a certificate of attendance showing that you've completed 1.5 hours of instruction following the webinar. So that information will be coming to you a little bit later. I'll try to drop some of those links into the chat pod. I'll follow up with an email to you to make sure you have all of that information as well. Those are just a few bits of housekeeping. I think what I'll try to do today while the webinar is going on is monitor the chat or the questions pod. So if you have questions and you have issues that you're trying to deal with, let us know. We've also got our team from VHB here in support of this webinar can help us work through some of those issues if they come up. So those could be technical problems. If you have questions that are related to the presentations themselves, you should know that we are holding about 30 minutes at the end of the webinar for Q&A. And so that is the time when we plan to get through as many questions as possible. So if you have them, please do send them in, and we'll be monitoring those and saving them for that Q&A period at the end of the webinar. Without further delay, what I'd like to do next is turn things over to our first introduction from Elizabeth Hilton to offer a perspective from the Federal Highway Administration. So Elizabeth, whenever you're ready, please go right ahead.
Okay, thanks, Dan. Welcome, everyone, and thanks for joining us today. With this 2-part webinar series, FHWA wants to put additional focus on the safety, mobility, and accessibility needs of pedestrians who are blind or have low vision. This user group has unique needs that should be considered when developing transportation projects and deploying safety countermeasures. While practitioners have become more attuned to the needs of pedestrians with mobility disabilities, The needs of pedestrians who are blind or have low vision are often overlooked. Under Title II of the ADA, state and local governments are required to take appropriate steps to ensure that their communications with people with disabilities are as effective as communications with others. What does that mean in the public right-of-way environment? What issues do we need to be thinking about as we develop our programs and projects? As we'll see in these webinars, we need to realize that information provided only in visual formats is not going to be available to pedestrians who are blind or have low vision. I look forward to the information our speakers will share to help us learn about the needs of this user population. And thanks again for joining us. And with that, I'll turn it back over to Dan.
Great. Thanks so much, Elizabeth. What I'm going to do now is I'll stop sharing my screen. And Janet, if you want to go ahead and pull up your presentation, I'll let you know when I see it, and we can get started with that portion of the presentation. Okay, great. Janet, you're all set. Oh, you might still be on mute. I don't hear you yet.
Am I up now?
There you are. Yep.
Oh.
Thanks, Janet.
Yes, I was still on mute. Sorry, I thought I'd unmuted it and it hadn't unmuted. So I'm going to start out this afternoon by giving you a little background on blindness and low vision, then some brief intro to some of the techniques and strategies used by people who are blind or who have low vision in traveling in the built environment here. My slides aren't advancing.
If you click back on the presentation, sometimes that'll, yeah, there you go.
Okay. So first, one of the questions I often get asked is how many people are blind or have low vision in the US? And that's really a difficult question to answer. There's no registry of individuals who are blind or who have low vision. And low vision and or visually impaired is often, there's no definition that's universally used. So sometimes how it's defined varies in different reports or in different studies. I tend to go with the information from the 2017 National Health Interview Survey, which came up with 26.9 million American adults age 18 or older have reported experiencing vision loss. That doesn't include those under 18. It also, I don't believe that survey included those who were in nursing homes or other assisted facilities. There's a photo on the screen of an older man with his hand on a push button device. Just in talking about low vision, it's important to realize that low vision is not totally blind, but there are limitations in vision that can affect the travel in the public right-of-way, and particularly safety at street crossings. Low vision may affect the ability to see signals, both the vehicular signals and the pedestrian signals, leaving those with low vision having to essentially guess from the traffic movement about the timing of the signal. It can affect their ability to judge the traffic's movement and speed and distance, and also the whole understanding driver's intentions. Often people say, oh, you know, look to the driver on whether they're yielding for you or something like that. And it's not so easy to do when you can't see the driver waving their hand to tell you to go across the street. That really can be important at unsignalized crossings, but it also can affect street crossings, thinking about right turning vehicles or left turning vehicles who are supposed to yield to pedestrians in the crosswalk. Depending on the level of vision loss, a person may not be able to easily find the crosswalk location. They may be depending on markings or marking type and may have difficulty with seeing curbs or curb ramps or islands. We also have a growing older population with low vision. For them, particularly, vision can vary with different lighting conditions. They may have reduced contrast sensitivity. That means that they would need more contrast to see objects, and that can include things like the white pedestrian signal against the background of a sky. They may react more slowly and move more slowly in general. Photo on the screen is of a older person wearing sunglasses approaching a sign which protrudes from the post at head height. Looks like his head is going to hit that sign if he continues forward at that direction. Got on the screen now a picture of an intersection, which I've labeled as seen by someone with normal vision. The photographer is looking across the street at a crosswalk at an urban signalized intersection. There's a parallel streets on the left. Both streets have 4 lanes of traffic, wide sidewalks. There's buildings at the back of sidewalk. Many of you may have seen this series of photos before. I've used them in many presentations over the last few years, but just look about it and think about some of the features that provide information about crossing to those who are sighted. Here's the list I have right off. The marked crosswalk, the edge of the street, the curb, the edge of the sidewalk and grass line, curb ramps, poles, pedestrian signals, vehicular signals, that pedestrian that's walking across the street, the cars that are moving on both streets or stopped on one street moving on another street, street signs and buildings. Those are all things that are used or could be used by somebody with typical vision in making their decisions about crossing the street or in maintaining their travel across the street. The next slide has a photo of the same scene with, which is very fuzzy, grayed out look. This would be similar to the vision of someone who has a overall reduced visual acuity. And look at this and note what is still visible here, might be used by those with some vision, or in this case. My list is the crosswalk lines are still visible here. Cars, if their color contrasts with the background, some of the poles, the color difference between the sidewalk and the street. It may be possible to read the sign in the foreground if somebody's close enough, or the pedestrian in the crosswalk may be able to see, somebody may be able to see the pedestrian in the crosswalk if there's enough contrast. However, a person with this type of vision can't really see the pedestrian signal, also can't read the street sign necessarily or the signal, vehicular signal clearly. And just a note, many individuals with vision similar to this do not use a white cane or other aid that identifies them as visually impaired. So you might not recognize that there's someone visually impaired walking on the street you designed or traveling in that area, but they may be missing a lot of the information that they may need in making that street crossing. Next photo is the same scene with some, as it might be seen by somebody with a major central vision loss. It's the same photo with a blacked out area in the center. This is representative of the most common cause of vision loss in elderly adults. This is a very advanced case, but basically the macula is our area of sharpest visions, which is used for reading and seeing details. Peripheral vision is always less sharp, as is shown in the photo. So in this one, this person probably can still see the edge of the street, the crosswalk lines, some cars if the color contrasts with the background. What a person with this type of vision loss cannot see is the pedestrian signal and can't read the street signs and other details. They also may use no aid such as a cane or dog guide that identifies them as blind to you, but they aren't able to see some of the details that can be really important in traveling and particularly in making decisions about street crossing. Next photo is the same street intersection again with just a very clear section in the center, a little jagged outline of a not quite a circle. It illustrates the severely restricted peripheral visual field, sometimes called tunnel vision, often caused by a disease called retinitis pigmentosa or glaucoma. For this person, what's still visible? There's a small section of the crosswalk lines if they're looking that way, a portion of a car, the pedestrian signal. They can probably see the pedestrian signal as long as they're focused on it, but the curb ramp, sidewalk, and cars are then not visible, or at least not while the person's looking at the signal. So they may miss oncoming vehicles in different lanes, might be able to see signs, but not the surface that's beneath their feet while they're looking at the sign. May miss something at head level if they're looking at their feet. These individuals with vision like this have to scan to see objects and only can see some parts of the intersection at a time. Probably with someone with a severe vision loss of this would be using some kind of long white cane or dog guide. And of course, then there are people who are totally blind. A person, the screen's completely grayed out here, a picture of the intersection. A person who's totally blind has no visual information at this intersection, but there are other techniques they can use to evaluate the intersection and to cross. They don't have access to things like the crosswalk lines, the visual pedestrian signals, or other features. And they're using other senses to gather information needed for travel to cross streets. But they do cross streets and travel independently. Some of the transportation choices for individuals who are blind who have low vision, they're usually unable to drive themselves to destinations, although there's some low vision drivers with specific restrictions and requirements and training. But options for non-drivers are to walk or use public transit, bus or rail. Some use paratransit services, taxi, ride services, or shuttles, and may also get rides from friends or relatives, or use paid drivers. Some of the techniques and aids for obstacle and curb detection. The most common is the long white cane. It's used as a probe of the walking surface. On the photo on the screen, there's a man with his cane extended in front of him walking across the street. Everybody has some choices about the aids and techniques they're using. They may use the cane in different manners, but basically it's used as a probe of the walking surfaces to detect changes in elevation or obstacles in their path. The white cane also identifies a person as an individual who's visually impaired. Another common aid is a dog guide. On this slide is a photo of a man crossing the street with a dog guide. Well, while many people think dog guides solve all the travel problems of individuals who are blind, that's not really accurate. Dog guides do guide around obstacles. They stop at curbs and drop-offs, but the dog does not make the decision about when to cross the street. The handler needs to make the decision and provide a command to begin the crossing. The handler also directs the dog along a route with a command such as right, left, forward, not with a command such as take me to the grocery store. Other aids that might be used by people who are blind or who have low vision might be a telescope, usually used only for specific tasks such as reading a sign. And some individuals may use no visible aid at all in traveling around in the environment. Some of the orientation and alignment cues that are used by individuals include various slight slopes and changes in surface texture. People vary in their ability to detect those differences, but individuals use various aspects of that. They might use the sidewalk or grass line or building line, following along that, or just listening to it and kind of moving off of the edge of the sidewalk when they contact it. They use the sound of traffic, both traveling parallel to their travel path and perpendicular to their travel path. When available, they may pay attention to and use other pedestrians' paths and movements, the sun, other cues. For orientation, it's also important to have some awareness of intersections and streets and general layout of an area. There are various ways that people gather that kind of information or have that kind of information, depending on their personal situation a lot of times. And for making decisions about crossing, there can be different cues about the time to begin crossing that are used at signalized and unsignalized intersections. At signalized crossings, there's usually a pattern to the traffic movement that can be discerned, and there may be an accessible pedestrian signal providing information. At the signalized crossing, the blind person is listening for traffic stopping on the street they're planning to cross, and for vehicles starting and moving across the intersection in the closest through lane, and where available, the message of an accessible pedestrian signal. At unsignalized locations, they're listening for hearing a vehicle approaching, not hearing any vehicles at all, hearing a vehicle yielding, or traffic moving parallel to the crosswalk. This can be sometimes quite difficult, excuse me, because the sound of one car or louder truck or something can mask the sound of other vehicles moving closer and closer by. So that can be somewhat precarious at times at unsignalized crossings, and particularly if it's more than one lane that needs to be crossed. But I want to emphasize that people who are blind do travel independently to new places. They are not oriented to every place they need to go in advance. They go to independently to someplace new for work, for some kind of shopping errand, for visiting friends, doctor's appointments, children's activities, all the kinds of places that a fully sighted person might go. They're more likely to be using transit and walking rather than driving. They may get directions or use some type of accessible GPS information. But I think most of us know some of that is not as good for pedestrians as it is for vehicles. As they walk along the streets and get to intersections, they usually have to figure out the crossings when they arrive at them. They may be unaware of changes, may at times make dangerous decisions when familiar intersections or areas have been changed, or when the layout is unconventional, such as some of the designs we may be talking about in these webinars. And thank you, Dan. We can turn it over to Rob now.
Great. Thank you, Jan. If you can stop your sharing, great. And then, Rob, when you're ready, you should be able to share your screen and go right into it. Wonderful. All right, you're all set.
All right, thank you very much. So for my part this afternoon, I'm going to build on what Janet has, on the foundation that Janet has laid already, and talk a bit about how people who are blind and visually impaired navigate the built environment, but how the built environment has changed over time so that the strategies that people who are blind and visually impaired have typically been taught to use in the last few decades has been shifting. Just to summarize some of the things that Janet pointed out, when a person who is blind is navigating a route out in the built environment, you can think of them as paying attention to two categories of information, nearby and more distant. So the nearby information is monitored often by the person using a device such as a cane. That gives them information about the immediate surroundings, where the grass line is, whether there's a curb in front of them, if there's a pole or fire hydrant nearby, that sort of thing. They typically use their hearing to monitor more distant information, cues and landmarks that are acoustic in the environment that they use to get a sense of their position. But one of the more constant, robust cues that they use acoustically is traffic. Traffic is historically a very useful bit of information for a person who's blind traveling around, because it alerts them to where the streets are, whether it's a one-way or two-way street, whether they're coming up to an intersection, whether traffic on a given street is stopped, therefore indicating they might be able to cross that street. So traffic flow is a very important cue for a lot of reasons, and we'll be seeing it later on in this presentation about how that is one thing that has changed dramatically in the last decade or so. But I want to also highlight the activity of crossing streets. As a person who's blind or visually impaired is traveling around, arguably one of the riskiest parts of traveling around is when they are crossing a street. And you can break that down into sort of 4 main subtasks. They need to be able to find the place to cross. A sighted person crossing an intersection that's light controlled generally stands in a certain spot on the corner. It may be marked with a crosswalk, may not, but you have an idea of where to stand. There may not be a robust tactual or acoustic cue for where that spot is for a person who cannot see that spot. And that is going to be location specific and situational. It differs for every crossing, really. So it's hard to say, always pay attention to this one cue or that one cue. And so that will take some tactual exploration by the person with the cane to figure out. The second part of the crossing task is aligning to cross. And the main cue there would be that flow of traffic. A person who's blind is taught and practices aligning themselves to both parallel traffic flow and perpendicular traffic flow. Some are better at one than the other, but across people we're equally good at doing either. But aligning to that traffic flow is a very useful strategy. But there may also be some tactual cues, like a return curb or a grass line, that a person can use with their feet or the cane to get a sense of how they should be oriented to cross the street. One of the problems here is that many cues that a person might use could be leading that pedestrian astray and actually lining them up incorrectly. If you think of a skewed crossing, it might be that if you line up with traffic, you're actually not aligned to cross along the crosswalk. And the person who's blind would not know that. If they ended up crossing incorrectly or with an improper alignment, it might very well be that they think that they themselves veered in their crossing, when in fact their initial alignment with the traffic was incorrect, and they won't know that unless they get feedback from, say, an orientation mobility instructor. So the third and potentially most important part of the crossing street tasks is deciding when to cross. And it seems to me that a lot of the technology solutions that have come about in the last years tend to focus on this aspect of the crossing task, getting information to the blind pedestrian about when to cross the street, or potentially just when the visual walk signal is lit. That's what the accessible pedestrian signal, or APS, does. There's a host of different kinds of technologies that are sort of along that line of getting information on when to cross the street. And then the last part of the crossing task would be crossing straight and getting to the far side in an appropriate amount of time, within the bounds of a reasonable crosswalk. For that task, far side beaconing has been shown to be helpful. If there is a sound on the far side of the crossing, that the pedestrian can orient toward and walk toward. That is very helpful, but that is a situation that's difficult to achieve. In the early days of APS, when we were looking at providing different kinds of signals in different ways, you can certainly set up an APS to provide a far side beacon, but if you have people crossing both ways on the same crosswalk, then you've got the sound from both sides, and that negates the value of the far side beaconing. There have also been some projects that looking at providing a raised tactile strip along the center of a crosswalk that a person could use their cane or their feet to follow and keep them crossing straight. That would also be a potential cue for crossing straight. But looking at the built environment itself, intersections, I have a picture on the screen of what we might think of as sort of the classic regular intersection. What used to be the norm. This is the kind of intersection you would tend to expect traveling around. It's a lighted intersection, 4 legs, very regular 90-degree corners, sidewalks going up to each corner with marked crosswalks. Excuse me. But a very regular, predictable, standardized kind of crossing situation. Nowadays, especially in urban areas, this is not so much the regular intersection you would encounter. You're going to get more complicated intersection types. On the screen now is call it updated intersection, a more complicated intersection at least, that has much wider streets. One of the streets has 6 or 7 lanes. There is a channelized turn lane on at least one of the corners of the street. So if a person were crossing this intersection from the bottom right part of the picture to the top right part of the picture, they would have to cross a channelized turn lane where the traffic theoretically doesn't have to stop, and then cross many legs of perpendicular traffic that is light controlled, and then perhaps cross another channelized turn on the far side, reorienting in between each of those crossing legs, making it a much more difficult task conceptually and auditorially and tactually. So this is more the kind of intersection that people are faced with wider lanes, longer crossing distances, and different kinds of crossing tasks. So unpacking that a little bit in terms of what has changed, very often pedestrians are faced with wider streets, more distant crossings. Right turn on red, when that became a law, that really changed how traffic flowed at intersections and introduced a new flow of traffic that a blind pedestrian needed to pay attention to. It doesn't always come into play depending on the intersection and the crossing the pedestrian is going to make, but it introduced one more element of complexity to the decision-making process. Then curb ramps became more prevalent. People who were blind were walking down ramps and into the street without realizing it, and so to address that issue, detectable warnings were designed and placed at the bottom of ramps. However, this can also introduce conflicting information, confusing information. One of the ways that curb ramps and detectable warnings can cause confusion is that very often the ramp and the detectable warnings are set up at the beginning of a crosswalk, but not always. It is often enough the case, however, that a pedestrian might get the idea that the detectable warnings are always where they should stand to cross the street. And while that might be true 90% of the time, 95% of the time, it isn't always true. And those few percents of the time where it's not true could lead to some fairly risky crossing situations. And then I showed one picture of a slightly more complicated intersection, but with new intersection geometries, with the advent of the roundabout, and now the new alternative intersection geometries, they introduce a whole new way of having to cross the street. It may not necessarily change the physical act of crossing that street, but they tend to change the flow of traffic. And that might change the kind of information that a person who's blind is paying attention to in order to make a decision to cross. Now I've talked a bit about how important traffic is. Quieter vehicles influence that by taking away some of that very useful traffic flow information. As quieter vehicles become more and more prevalent, the traffic flow is going to be harder and harder for a blind pedestrian to use. I'm going to take a little bit of time now to talk about signal timing. That has become more complex. Having actuated intersections has introduced a very high degree of complexity in the crossing task for a person who's blind. It used to be that you could walk up to an intersection, listen to a few of the traffic cycles, and sort of understand the general flow. With actuated intersections now, that might not be true from one traffic cycle to the next traffic cycle, certainly not from light volume to a heavy volume. And then if you introduce things like LPIs and exclusive PED phases to the signal timing, that introduces more complexity, more that the blind pedestrian needs to pay attention to. So let's just look at some of these fancy pedestrian timing issues. Start with the leading pedestrian interval. So this is where the pedestrian signal displays the walk for 3 to 5 seconds before vehicles get their green ball. And the advantage is that pedestrians can get into the crosswalk before vehicles begin turning right across that crosswalk. It gives them a chance to sort of claim that crosswalk. However, for a blind pedestrian, that walk signal happens before that parallel surge of traffic, which they often wait for as a acoustic signal of this is when you can cross. They sort of cross with the parallel surge. If the LPI gives the pedestrian walk sign before that surge happens, but there is no APS, then the blind pedestrian doesn't know that that has happened. They're still waiting for the acoustic signal from the traffic. The drivers aren't expecting you to cross because they're just standing on the corner, and so they will then start crossing. And here's also where right turn on red might come into play. Even though the vehicle has a red light, they could still turn right if there's not a no right turn on red sign posted. So one of the answers here is that if an LPI is put in, it needs to be paired with an APS so that a pedestrian who's blind can get the auditory information that that pedestrian walk sign is lit, and then get the benefit of having the LPI. In a similar way, the exclusive pedestrian phase. In this situation, all vehicles have a red, and pedestrians are allowed to cross on all crossings, sometimes even diagonally across the intersection. There may or may not be a no right turn on red posted for that situation as well. Now, for the blind pedestrian, the issue is they may not know that there is an exclusive pedestrian phase at that intersection. And when they're deciding when to cross, they get no traffic information at all because all traffic is stopped. And so it's very difficult for them to get a sense of their alignment, and then also when they should cross and where they should be heading as they're crossing. Again, pedestrians coming from their corner might be crossing in 3 different directions. And so it's hard for the blind pedestrian to figure out where they should be going. Again, here for the exclusive pedestrian phase, the addition of an APS can be a very useful cue. Just briefly, there is also an intervention, a signal intervention called a pedestrian hybrid beacon, sometimes called a hawk signal. These function differently than a typical traffic signal. They typically rest in dark, and they've got a group of a triangular orientation of 3 lights instead of a vertical orientation of 3 lights. They're only activated when the pedestrian presses the pedestrian push button. So they are a sort of a pedestrian signal, if you will. And when it's activated, there's a flashing, 2 lights are flashing, and then go to a steady yellow, and then a steady red, which drivers recognize as they need to stop. And then that steady red is paired with the pedestrian phase. That's when the pedestrians get their walk signal lit. And after that interval is done, there's a flashing red wig-wag of 2 of the lights, and then vehicles are allowed to go because the signal goes to dark again. The important thing here, just like in the LPI and EPP, is that they need to be paired with an APS so that the pedestrian who's blind knows when it is that they are able to cross the street. And these pedestrian hybrid beacons are very useful at crossings like roundabouts or mid-block crossings, places where traffic doesn't necessarily need to stop. There is no traffic signal, but there's enough pedestrian usage and the traffic volume is high enough that it would be useful for pedestrians to be able to just stop traffic for them to cross the street instead of trying to cross in a gap in traffic, which, given the particular situation at that crossing, perhaps with the traffic volume, there may not be gaps in traffic that come often enough or are long enough to allow for low-risk decisions on crossing by blind pedestrians. So it's important to have APS when you are using a pedestrian hybrid beacon as well. Now, a lot of these kinds of engineering solutions for crossing decisions, as well as other solutions, are found in a number of reports. There's a NCHRP research report 834 talking about crossing solutions at roundabouts and channelized turn lanes for pedestrians with vision disabilities. There's a current project, I think it's completed, NCHRP 725, that is also coming out with guidance for pedestrians at alternative intersections and interchanges. So there is guidance out there looking at different ways to make intersections more accessible to pedestrians with visual impairments. But the bottom line is that nowadays, signals and traffic flow are not as simple as they used to be. When we as orientation mobility instructors are teaching people who are blind to navigate the built environment, we have to talk a lot more about all the possibilities that might come about with the traffic flow and the signal timing at an intersection than we used to have to be able to do. You simply can't just walk up to an intersection, listen to it for a little while, and know how it's going to work the next time you come up to it. And there may not be enough information just from traffic to determine the correct time to cross. There's this increased complexity has meant that there is a degradation, if you will, in the kind and amount of information that a person who's blind has access to for making these crossing decisions. There are certain kinds of crossings that are particularly problematic. When you are crossing a street and there are low volumes of traffic that are parallel to the crosswalk. So if you're crossing from the top of a T intersection and you're crossing that top, you have no parallel traffic at all. Or if you're crossing even a major street and the intersection is with a minor street, you may have little to no parallel traffic. In situations like this, it can be very difficult to rely on traffic because it is either not there or it's there in a limited manner. These are also places where APS can be very useful. We've talked about the exclusive pedestrian phases and the leading pedestrian intervals, places where there's a lot of masking sound, maybe at roundabouts. These are also places where people who are visually impaired have difficulty making crossing decisions. Now, I mentioned early on that there's been a number of sort of technological or electronic solutions for a lot of issues for people who are visually impaired. And these have been of varying degrees of successfulness. And there have been a host of them over the years. So I don't want to get into all the different kinds, but in thinking about it, I thought you could break it down into a 2x2 matrix. Technology that is user-based or environment-based, and technology that either gives information about the environment or specifically crossing assistance. So user-based technology that gives environmental information, that might be something like a GPS unit, or a laser cane, or mini guide, or Trekker Breeze. These are standalone units that either clip onto the cane or are held in the hand. The mini guide is an ultrasonic device that vibrates in the hand when a large object is within its ultrasonic cone. There's been many different kinds of GPS units over the years. Many people just rely on apps on their phone nowadays. But those are the kinds of things, either information about objects in the environment or information about position in the environment, that are user-based. And environment-based environmental information technology might be like talking signs or Navalens. Talking signs is a infrared-based system where these signs would be placed within an environment and would be putting out a signal that a user could access if they had the receiver. Navalens is a project in Spain which posts within the environment things that are kind of like QR codes. They're just posted on the wall or at entryways, and if you have the proper device for accessing that code, then it would give you information about the environment, and it could be whatever information that people doing the system code into the environment, into the system. A user-based device that gives crossing assistance would be something like an app on the phone that is linked to a smart intersection. And there are a number of pilot projects out there doing these kinds of apps where the phone might simply allow you to press the push button for the APS from your phone instead of having to physically find it, or it could give you information about the status of the traffic signals, but it gives you some information that you use for making crossing decisions. And then the classic example of environmentally based crossing assistance technology would be APS, or accessible pedestrian signals. Those acoustic signals at the intersection that tell you a person when the visual walk signal is lit. So in summary, a lot of technology ideas out there have tended to focus on when to cross the street. Then another host of them tend to focus on obstacle detection or providing location information. But there aren't that many technological solutions that seek or that integrate all these functions in a functional manner. It would be nice to get something that does more than only one of these functionalities, so that a person doesn't have to try and juggle multiple devices or multiple apps in order to navigate successfully. And I think I'm about at the end of my time, so I think I will stop there.
Okay, wonderful, Rob. Thank you so much. If you could press the stop sharing, there you go. Janet, take the screen back if you can, and I'll let you know when I see your slides up. We'll get through this final presentation here. As Janet's doing that, just a reminder, some of you, I see you have your hands raised. If you can submit those questions through that questions pod, that's where we've got them all coming in, some really good ones that we can get it to in the discussion right after this. So Janet, I see your screen and you're all set to go.
Yeah, I'm going to talk now particularly about accessible pedestrian signals that we have out there on the street today, some of the standards for those signals and some innovations going on and issues related to that. To start with, people, as I noted in the slides earlier about how blind pedestrians travel, there's lots of different types and severities of vision loss. People who are blind or have low vision, even if using no aid such as a cane or dog guide, may not be able to see the signals and need that information about the status of the pedestrian signal. Using the traditional method of listening to traffic movement and sounds was found to result in an average delay of 8 seconds after the walk interval begins. Many of you may be familiar with a typical walk signal, maybe only 7 seconds. This was basically because people who are blind have to listen for traffic to get to the middle of the intersection to know the vehicles are going straight and not making a right on red. To deal with the potential turn arrows, they need to rely on the traffic that's in the closest lane traveling beside them. And so in some locations, when that street is on their right side, they may be listening to the traffic that's coming from all the way across the intersection, which adds to the delay time and makes it harder to hear the surge of that traffic beginning. So using the traffic is essentially kind of guessing on that a little bit. There's some standards and guidance out there that relate to accessible pedestrian signals or have led to some of the things related to pedestrian signals. We have general accessibility requirements in the implementing regulations of the Americans with Disabilities Act. There's also more specific standards and guidance in the 2009 MUTCD and some in the 2011 proposed accessibility guidelines for pedestrian facilities in the public right-of-way, usually referred to as proposed PROAG. Both the PROAG proposal and the MUTCD standards were based on research in 2 concurrent projects that were happening between 2000 and 2007. A National Eye Institute project titled Blind Pedestrians Access to Complex Intersections, and NCHRP, National Cooperative Highway Research Program Project 362, which was on guidelines for accessible pedestrian signals. These 2 projects had extensive testing with blind participants crossing streets at unfamiliar intersections. The NEI project focused on before and after installation of APS, and the NCHRP project looks at different types of APS and installation locations to determine what worked and what didn't work for individuals who are blind. All the crossings involve blind pedestrians independently making decisions about crossing at intersections. Just to go quickly over these regulations that you need to be aware of, and Elizabeth mentioned this earlier, that the implementing regulations for the Americans with Disability Act are published by the Department of Justice. basically say that public entities need to be certain that their services, programs, activities are readily accessible to and usable by individuals with disabilities. That's a language that I think everybody needs to remember as they're doing design and thinking about facilities. As Elizabeth mentioned, communications with applicants, participants, members of the public, and companions with disabilities are need to be as effective as communications with others. And basically that public entities need to furnish the appropriate auxiliary aids and services. It's not something the person has to have, but something the public entity needs to provide to allow individuals with disabilities an equal opportunity to participate and enjoy the services and programs of an entity. So these are overarching requirements to be considered when you're building stuff and looking at things. In proposed PROAG, it's not a final rule. It provides some guidance that could help in responding to that Department of Justice requirement to make the intersections, quote, accessible to and usable by individuals with disabilities, end of quote. Proposed PROAG would require APS where pedestrian signals are installed. It refers to the MUTCD, the Manual on Uniform Traffic Control Devices, for the device and location specifications. The 2009 MUTCD provides several specific sections that relate to push button location and to APS. There's guidance on push button location in Part 4, Section 4E08. And there's standards and guidance regarding accessible pedestrian signals specifically in Part 4, Sections 4E09 through 4E13. There are other references at other locations in the MUTCD about accessible pedestrian signals and places where they might be considered or should be considered. But these are specific specifications in these areas I'm going to talk about today a little more. In the general information and standards in the first part about accessible pedestrian signals, one of the things that's stated is that the accessible pedestrian signal needs to clearly indicate which pedestrian crossing is served by each device. They're not to be limited in operation by time of day or day of the week. And that if a accessible pedestrian signal is installed, with push buttons, the push button needs to activate both the walk interval and the accessible pedestrian signals. Some of the required features of APS, and these are important for everybody to remember that these are the features of accessible pedestrian signals that need to be there for their usability by blind pedestrians. And this is stuff that's been determined through the research that was done a number of years ago. These are specific features outlined in 4E09 through 4E13. And I'll talk a little more about each one of them. There's push button locator tone, the audible walk indication is audible at the beginning of the associated crosswalk, a vibrotactile walk indication, a tactile arrow that vibrates during the walk. Locator tone and walk indication volume are supposed to adjust in response to the ambient noise levels. And there's a tactile arrow that's aligned parallel to the direction of travel on the crosswalk. It should have high visual contrast. Just an example of a accessible pedestrian signal, the sounds that it makes. The push button locator tone is sounding during the don't walk and flashing don't walk. And then there's a rapid tick walk indication is the standard walk indication. I'm just going to play those sounds for you of the first you'll hear the locator tone and then the rapid tick, and then go returning to the locator tone during the flashing don't walk. The other option in some locations is using a speech walk indication. That's only supposed to be used in certain types of situations, but I'll just play you an example of that as well. Locator tone.
Lincoln Avenue. Walk sign is on to cross Lincoln Avenue. Lincoln Avenue. Walk sign is on to cross Lincoln Avenue.
A little more about the features that I was talking about. The point of the push button locator tone is to let a blind person know that there's a push button there and to help them find the button. The sound comes from that push button. The repetition rate, the length of the tone and volume are specified in the MGCD. The type of tone can vary. The repetition rate specified at 1 tone per second, with each tone less than 0.15 seconds in duration. That's so it doesn't get confused with backup beepers or other tones used in the work environment. Volume is supposed to be set to be heard only within 6 to 12 feet of the push button or at the building line, whichever is less. These are not supposed to be loud, heard all the way down the block. And different sounds are acceptable, as you maybe heard on those 2 recordings I just played. A click tone or a beep tone or something similar could be used for that one. Audible walk indication is required to be audible at the beginning of the associated crosswalk. In most cases, the rapid tick walk indication is what should be used. It was more detectable in traffic noise in the research that we did, as well as leading to less errors in decision making. To use that effectively, the 2 APS or the speakers for the APS for the 2 different crosswalks need to be separated by at least 10 feet. When you can't separate them, particularly in locations with when you're doing alterations, speech message needs to be used, and there's standard language required and also additional message required. The speech message, push button information message needs to be provided in order to give the blind person the information about the name of the street. There's also a requirement for a vibratactile walk indication. This is an arrow that vibrates during walk. Obviously has to be low enough or at hand height or height that a pedestrian can touch it during the walk to know that it's vibrating. It's particularly useful to pedestrians who have hearing and visual impairments, but you have to be standing with your hand on the push button to use it. So the location of the push button and device is really critical to the successful use of the vibratactile walk indication. If the push button's too far from the curb or oriented in a manner that doesn't point toward the crossing, the individual will be delayed in beginning their crossing, could possibly become disoriented before even getting to the street. There's also a requirement for quiet volume, unless specific audible beaconing is called. The volume of these APS are not intended to be heard all the way across the street. It's only supposed to be 2 to 5 dB over the ambient noise level, audible within 6 to 12 feet of the push button, audible at the beginning of the crosswalk, whatever's closer, but it's not supposed to be audible all the way down the corner, across the street. Really, this means that the pedestrians who are blind need to go to the crossing point and listen for the locator tone to determine there's an APS, go back to the beginning of the crossing, push the button, and go back to the crossing. Audible beaconing, if that's used, is called by pushing the button and holding it for more than a second. I'll talk more about that later. There's also supposed to be a required feature is automatic volume adjustment. So the volume of the push button locator tone and the walk indication adjust in response to the ambient sound. So it's louder when traffic is loud, quiet when traffic is quieter, like at night. Should not be set to be higher than 5 dB over ambient. There are also minimum and maximum volume settings within the device. These need to be adjusted for specific locations. Often that's not done well by installers. There's a requirement for a tactile arrow. This is a raised arrow. It's supposed to be aligned with the direction of travel on the crosswalk, controlled by the push button. Maybe on the push button or the device above the button itself. It vibrates during the walk, but definitely should be aligned with the direction of travel on the crosswalk. Shouldn't be pointing toward the middle of the intersection. It's that arrow may be used by some blind pedestrians to line up for crossing, so it's a critical detail to consider that the arrow doesn't point out to the center of the intersection. And overall, device location is critical. It provides information to the user by being closer to the departure point. That's what part of how this newer push button integrated APS work. Many of you may be familiar with the older cuckoo chirp devices. They were found to be confusing. Among other things, users had to remember which sound was for which direction, had to know what direction they were traveling. On this newer type device, the location provides the information through proximity to that departure point. If close to the crosswalk, it doesn't require the blind pedestrian to figure it out. They can recognize, I pushed the button on my right, the walk indication's coming from my right, that's the sound for my crosswalk. It also can be quieter due to the proximity to the crosswalk location. This type of device and installation location has been used for years in Australia, Sweden, Denmark, other countries. The graphic on the screen showing installation location recommendations. It's one corner of intersection with streets across the top and on left of it. There's symbols on the graphic. There are 2 poles and 2 push button integrated APS shown. Each is located at the top corner of the curb ramp for the crossing on the side furthest from the intersection center. The arrow points toward the streets in line with the crosswalk direction. So if a pedestrian is facing toward the left, there's a pedestrian that's shown facing toward the left, crossing that's on the left in the drawing, waiting on the curb ramp. The pole and APS are on his left side and the parallel streets on his right side. Installation close to the crosswalk departure location is essential. MUTCD has language specifying that the APS should be beside a level area within 5 feet of the crosswalk line furthest from the center of the intersection. The device is supposed to be mounted within 6 feet of the curb. MUTCD provides an exception allowing it to be up to 10 feet from the curb. And the devices themselves, 2 APS on the corner, should be separated by at more than 10 feet to eliminate the confusion of the sounds. Photo on the screen showing some potential installation locations. Looking across the street on the sidewalk, there's a parallel street on the right. The pole and push button for the crossing that street are in front of the photographer there. And note that those push buttons are near the departure point on poles separated by more than 10 feet. They're not right by the level landing of the curb ramp, but beside the ramp where there's a level area at the push button itself. The push button on the right is located on a short stub pole. Another installation example where the 2 poles and APS are separated by at least 10 feet. There's a pole and APS device next to each curb ramp on the side of the ramp furthest from the center of the intersection. Ramps at this location have a very low slope, and the push buttons are actually beside the ramps in this case. Other possible features that are mentioned in the MUTCD, they're not required features, but could be installed and are available on some devices. They include an actuation indicator, Braille street name labels, crosswalk maps, push button information messages, and audible beaconing, which is recommended at some types of crossings. The pilot light or actuation indicator is a light that is illuminated when the push button has been pushed. There's a photo on the screen showing the actuation indicator illuminated. A yellow circle is on the photo around the light area. it could also illuminate when the signal is called at pre-timed locations to let sighted pedestrians know the push button has been pushed, or it's called, the walk has been called. Audible beaconing is a feature that can be added and is recommended in the MUTCD for large and complex crossings. For successful audible beaconing, an additional speaker is mounted on the pedestrian signal head, and the locator tone sound is boosted during the flashing don't walk from the speaker that's only at the far end of the crosswalk. MUTCD currently has descriptions of other types of audible beaconing, things like the sound alternating on the two ends of the crosswalk. But basically some research we did found that didn't work well for many of the participants. The type of audible beaconing that worked well is called by holding the push button in for more than 1 second, and then the louder sound is broadcast from the far end of the crosswalk from only that crosswalk during the flashing don't walk, not during the walk, and only for the crosswalk where the beacon has been called. Photo on the screen shows a small yellow speaker with a swivel mount so it can be aimed properly in line with the crosswalk. And graphics shows an additional speaker mounted on the pedestrian signal, shows that additional speaker mounted on the pedestrian signal pole. The walk is displayed, and graphic indicates the sound is coming from the push button device during the walk, not from the overhead speaker. Tactile crosswalk maps are another options that are allowed and are being experimented with in some locations. There's a graphic on the front of the APS sign for each crossing. At this time, there's no standards in the US for symbols. On the photo on the screen, raised symbols represent vehicle lanes, bike lanes, medians, train tracks. There have been very little testing of the effectiveness and legibility of these symbols. And that's something that probably needs to happen before they're used very consistently. Just a note that audible countdowns are not currently allowed by the MUTCD. They're used in many locations, and people think that sounds great, but that sound of that speech of the countdown is a more constant sound than that locator tone. It's less localizable than the locator tone sound. Speech can fuzz, basically. Can mask the sound of traffic that blind pedestrians may need to hear. And as one person said to me, I'm already going across the crosswalk as fast as I can. I really don't need to know I only have 4 seconds left when I don't know how far it is to the end of the crossing. So basically right now the MUTCD says the accessible signal shall return to the push button locator tone during the pedestrian change interval. There's been recent possibilities and additions, ideas for different ways to provide information to blind pedestrians. A lot of it's Bluetooth communication or various apps. Talk a little bit about those. Basically, Bluetooth communication to APS devices has opened up some options for more information. One thing is they can allow signal text to adjust features remotely or without actually opening up the APS or the pedestrian signal head. Also could allow a user with an app to push a button for the phone or other fob type device. They may provide other intersection signal information. It's important for any app to call only the desired signal. Otherwise, it could call both signals. At this point, it seems that various fobs or apps are not accurate enough to provide walk information. Important to recognize these optional features should be in addition to required features. At this point, there are no standards or standardized language for how to provide other information about an intersection in a way that would be used accurately and consistently by all users. There also can be some options for Bluetooth communication between APS devices. A device wired just to the ped head may be able to communicate with the APS at the other end of the crosswalk. which might help in providing audible beaconing without running new wires back to the controller, or to provide that actuation indicator to know that the push button's already been pushed for that crossing. May be particularly helpful in retrofit situations, and I'm sure we'll see other possibilities in the future. Just a note that handheld or personal devices are being suggested, and there's an assumption by many that these will replace having to provide that APS equipment on the corner. I want to strongly discourage that thought among transportation professionals and pedestrian advocates. A personal device, whether it's a phone or a special fob distributed, really doesn't replace an APS that's available on the street any more than a similar device would replace the visual pedestrian signals. Individuals who are blind, elderly, deafblind should not have to know about a special program or get special device in order to access our basic pedestrian signal information. You know, when you look at handheld or personal devices, even if the person knows about that special program, they may leave that device at home, the battery may be dead. How many of you had a cell phone die during the course of a day? I certainly have. They may already have their hands full with a cane or a dog guide and carrying other items. At some locations, that individual may be unable to use the device effectively or may somehow misunderstand its message. And many may be unable to afford to purchase or maintain an extra device or app. You need to think about these devices as being supplemental to the APS and pedestrian signal information you're providing. Just in general, summary, to know when the walk's displayed, APS are needed by pedestrians who are blind, who have low vision, by many elderly pedestrians. It's particularly important in intersections with protected turn, leading pedestrian intervals, exclusive ped phases. We do have these standards that are based on research. I encourage everyone to be aware of the standard and use them in APS installation and not get too distracted by new fancy devices and options that are out there. There's a lot more information at a site called apsguide.org. I've also, on the next few slides that I'm not reading through them, listed some of the research articles that were used in developing the standards for APS. And thanks for your time this afternoon.
Wonderful. Thanks so much, Janet. I've got a slide that I want to put up to help guide our discussion period. We'll get to as many of your questions as we can. I wanted, though, for you all to have contact information for our panelists, and it is available in the slides. I also wanted to note briefly that Janet's included several more slides of reference material that is included with the PDF archive. So if you want to look back and kind of drill down to some of those references and resources, they are there for you. But I wanted to get through some of these questions. Luckily, a lot of your questions kind of had some similar threads to them. So I'm hoping to ask multiple questions at once to our panel. Janet, the first I think is for you, but others, please jump in. For locations with pedestrian recall, or where push buttons are not used, but the pedestrians get the walk sign every time. And you may have covered this, I apologize if I missed it, but what's sort of some of the guidance on APS and those audible indicators in those situations? Are they going to be going along with those automatic walk signals for peds, just anytime the signal comes up, or since there's no push button, or is there audible or automated detection that lets it know when a person is there and that's when it goes off?
At pre-timed locations, areas when the walk, I personally feel that whenever the walk signal comes up, there should be an audible and vibrotactile indication for the blind person as well. Note that you can't just do audible, it needs to be vibrotactile as well. So these push button devices are probably options that need to be there. You don't necessarily have to push the button to get the walk, though. It can be set that whenever the walk comes up, the audible comes up. And remember, these are devices that are quieter. They're set to be heard at the beginning of the crosswalk, not all the way across the crosswalk. I think a lot of people think, oh my gosh, they think about the old cuckoo chirps going off and being loud to hear all the way across the street. And we found those didn't work. And so need to be setting these devices to be heard at the beginning of the crosswalk and not really loud. And so the option of calling the audible beaconing could be there at a place where things are on ped recall, so that if somebody needs that louder signal, they could get it. But it would, certainly be my advice that the walk comes up whenever the visual walk comes up, that blind people get that information as well.
That's really useful. One of the other questions that came up very often from several people is one I'd like to ask actually Elizabeth, because you and I were chatting about this a bit. Signals, we've got a lot of good guidance there, and Janet's walked us through a lot of that. We also know about these other systems for other uncontrolled crossings, the pedestrian hybrid beacon and the rectangular rapid flashing beacon. And there are it sounds like there's a spectrum of available application of APS at those locations, though you can't use the full toolbox of APS, it doesn't sound like, at a rapid flashing beacon. Could I ask you to help identify some of those differences for us? I think those are valuable to know.
Well, I would suggest looking on the Federal Highway MUTCD team's website, which is mutcd.fhwa.dot.gov, for specific interpretations and so forth. But the interim approval for rectangular rapid flashing beacons specifically talks about accessibility and the use of APS. And for instance, you don't want to use a standardized signal or messaging, whether it's that would suggest a walk light is on, because that might imply that traffic is stopped. And at a rectangular flashing beacon, it's a warning beacon. It's not a red stop indication. So, we have to be a little bit careful. And the interim approval for our RFBs talks about the limitations, but APS can be beneficial and help people realize where they're crossing and find the crossing and so forth. So Janet might have some more comments on that.
Janet, anything to add to that?
Not particularly at this point. I mean, there certainly are options for like at a pedestrian hybrid beacon, you can use a typical walk indication APS, but when you're looking at the locations like our RFBs, you need to use something different. So I think there's been a little bit of work on that and research we did on their use at roundabouts, and they did improve the crossings of blind pedestrians in those locations.
Thank you for that. Rob, I have a question for you, and that what you did in the beginning of your presentation was really valuable in walking us through how all of these changes over time have really impacted the way that that blind and low vision individuals are able to get around. And agencies are charged with developing transition plans for how they can get their streets and intersections and public rights of way into accessible shape and into the requirements to align with the requirements we've laid out nationally. And we had a lot of questions from folks who were saying, if we're doing a transition plan, what are some of the key priorities we need to be making sure, things we need to be looking at, both the things that are on paper, letter of the law required, but also what are some recommendations for how we can reverse that transition and get things back into the shape where they really can be more accessible. And I wonder if you had any thoughts, giving that sort of the big picture view on some high priority items that agencies should be looking at for those transition plans.
Well, I mean, that's a very thorny thicket to get into. But I think one of the best tools for getting at that, given that every municipality, every city, every situation is going to be a little bit different, is to do a walkability study or a pedestrian audit for walkability, so that the city could have people from different disability groups, from different populations within the city that can walk through an environment and give their feedback on the accessibility and walkability within that audit process. I think that's a very valuable tool.
Excellent. Yeah, no, that certainly does make sense. I wonder if Janet, you had talked a little bit about some of the public outreach components of and ensuring that those are accessible, and that seems to be building on what Rob is saying as well, is ensuring that you are providing that level of input to those plans from those who are actually needing their voices heard when making things more accessible.
I think that's certainly important, and it's really sometimes quite difficult kind of to get the word out to individuals who are blind, or for them to have feel comfortable in coming to some of the public information sessions that are maybe provided. I know a number of years ago had brought several blind participants to a information system presentation about making streets more pedestrian friendly, and the speaker kept showing slides and saying, as you can see here, and the blind participants would raise their hands and say, I can't see what's there. And it was just so typical of the public input session, and that speaker had the hardest time trying to switch to not just assuming that everybody in the audience could see what was on the slide or what was in the on the map. And so getting information to people in accessible formats is really important. And I think really just looking at some of these features in terms of the kinds of things we're talking about here can really help cities be more accessible to people who are blind, who have low vision.
That's wonderful. I totally agree. And I hope that this information is useful in helping folks do that. You're looking at your clocks, I'm sure, and seeing that we're at the end of our 90 minutes together. So unfortunately, I have to be the one to close off the discussion for now. But I want to just let everyone know we will be back on Thursday for episode 2. I'll be emailing information how you can access that. Rob and Janet will be back. We're going to have a couple of other panelists join us as well, get into some issues about wayfinding and navigation and how we really line up and get across the street, and talk about some locations like roundabouts and other areas that I know you all are concerned about. You asked some questions. We'll be getting into some of that detail in episode 2. I'm just sent out a link in the chat to where you can find your certificate of attendance. I'm going to send a follow-up email with a lot more detail about where the archive page is, where the recording will be, where the copy of the slides will be, all of that right there on our website. You can find it right now, I'm sure, if you go to pedbikeinfo.org/webinars. And we'll send out the link for the Thursday meeting on Thursday morning, so it's fresh in your inbox right there. If you have questions for us in the meantime, please get in touch with us. That general account there is a great place to send your questions. We'll be monitoring that and responding right away. But I just want to say a big thank you again to our panel for coming today and sharing their perspectives. I'd also like to thank all of you for taking time out of your day to talk about this with us. We'll see you again, hopefully on Thursday. Thanks very much.